Welcome to Study Loop.
Okay, so we're doing chapter 29, problem 53. Okay, so we have this diagram over here. So this is a circuit, a flexible circuit that has a loop here, and it's connected to a resistor, and it's all in a magnetic field into the page. So that circle on the end has a diameter equaling 6.5 centimeters, so a radius of 3.75 centimeters. Oops, sorry, 3.25 centimeters. Okay, and the magnetic field strength is 1.35 Tesla. So at a time equals 0, what happens is there's this loop, this flexible loop gets pulled from the bottom and from the top such that at a time equals 0, it is perfectly in a circle, so the area is pi r squared. And then in a delta t of 0.25 seconds, they squeeze it just so it's flat, so there's no area left. So it goes from this, squeeze, flat. Okay, it does it in the time delta t. Awesome. So what we want to do now is figure out what is the average induced EMF on this, just the magnitude. Okay, so this is given as the change in magnetic flux over the change in time, and that is given as B A final minus B A initial over delta t. Since our B is constant in this case and only the area is changing, so now we can just plug this in. We have B times negative A initial because A final is 0 for delta t. And this, we can now plug it all in our calculator. We have 1.35 Teslas times pi over 4 times 6.5 centimeters squared. And then all over 0.25 seconds. So when we convert all those units right and plug it in our calculator, we should see this is 0.018 volts. And that's our average EMF during that time. Cool. So now for part B, let's figure out, does the current flow from A to B or B to A? So the magnetic flux through this loop is into the page, and as the area decreases, the flux decreases, so it's decreasing. So Lenz's law says the induced magnetic field must oppose the change, which means we also want this to be into the page. So now what current gives you an into the page? Clockwise. Clockwise gives you into the page, so that means we're flowing from A to B. Cool.